Alright, we're going to go on with Euclid's Elements with Euclid Book 2, proposition number 4. Okay? Now, Euclid says the following. That the square here, we have a square, we're going to draw this. It's going to be A, D, E, B. Okay? A, D, E, B. I'm going to go real slow on this. He says that that square right there is the sum of the square of H, D, F, G, which will actually be relabeled as A, C, D, F, and I'll show you that in a little bit, and the square of C, G, K, B, I'll go that again, C, G, K, B, which will not be relabeled. That square stays put. So it's the sum of this square and the sum of this square plus twice this square here. You're gonna have the area here multiplied twice. Then you're gonna add it to this and to this, and it will become A, D, E, B, or at least the area will be. Alright, now I know that's going to be very confusing right now, but we're going to go into this, okay? First of all, you're going to do some line drawing. Obviously, you're going to make a square by Euclid Book 1, proposition number 46, and that square is going to be A, D, E, right down here, there's the E, and there's the B. Okay? Now then, you're going to start using Euclid Book 1, proposition number 31 to, first of all, draw a line from point B way up here to point D way down here. Okay? And then you're going to draw yet another line from point C way up here to point F way down here. And then, where BD and CF cross, you're going to have a point called letter G. And you're going to draw a line from point K to point H that's going to pass through point G. Alright. So far, so good. Now, since CF, this is CF here, is parallel to AD, which is way over here. These two lines are parallel. CF and AD are parallel. Then we can actually say that CGB, this is C, this is G, this is B, this angle right here is equal to ADB. ADB. These two angles right here are equal. And the reason why they're equal is because these two lines here are parallel. And if you don't believe me, you can go back to Euclid Book 1, proposition number 29, and it'll tell you that right there. Alright. Now, we also know by Euclid Book 1, proposition number 5, that angle ADB, this one right here, is equal to ABD, this one right here. So this angle here and this angle here are equal. Now the thing is, angle CGB is now equal to angle CBG because of the transitive property. If this angle is equal to this angle and this angle is equal to that angle, then and so on and so forth, you can go around the out bush. Okay, these three angles, this one here, and this one here, are all equal. Different reasons, but they're all equal. Now that's going to make line CB right here, equal to CG in length. And why is this? Because of Euclid Book 1, proposition number 6. Now, we can take this one step further. CB equals GK, and, well, no, I'm sorry, CB equals CG, which CB here equals this one here, Okay? And CG equals KB. And the reason why this is true is because of Euclid Book 1 proposition number 34. Now that actually then now all means that CGKB is a square. Well, it's actually equilateral. It actually is equilateral. Now because CG and BK are parallel, then angle KBC, this whole angle right over here, I'm going to put a star right across here, there's a KBC, okay, is going to be plus angle GCB, so you got GCB, this angle right here. The sum of these two angles right here is going to be 180 degrees. And this is by Euclid Book 1 proposition number 29. Now, we've already established that KBC is a right angle because EBA is a right angle. And if EBA is a right angle, then certainly KBC is going to be a right angle. Okay? Now, since we said the angle KBC plus GCB is 180 degrees, and we've already established that KBC is right, then we should also conclude that BCG, this angle right here, is a right angle. Okay? So KBC is a right angle, and BCG is a right angle. Alright, I will tell you the rest of this proof in my next video, so stay tuned.